Because the shot glass is solid. You'd be like, oh yeah, how to get in the cup, but like you knew it wasn't in the cup because you just saw the inside of the cup.
That's even better. That's really.
It's like he'll take like and the thing is.
He's here somewhere.
Yeah, there's actually a card. One of the great legends in card magician, Darwin Ortiz, lives around here.
Oh yeah.
Like actually literally within walking distance, which we didn't even know. Like we just the hotel, right?
Okay.
And so he was like, yeah, actually it's like I mean it's up like by Wisconsin or something, so it's like 29th or something. But that's where his apartment is, so it's like I could actually walk there. I was like, okay, great. So he's been.
You should walk by and stalk him. Just knock on the door.
I keep telling him I'm like, dude, you gotta you gotta play poker with some of these guys, or just like show what you can like totally pwn a deck of cards.
Yeah.
But yeah, no, he's pretty good. He's one of the top amateur or whatever. Like I mean, he doesn't perform or anything, but it's just one of those on whatever forums or whatever they get together and we can do amazing.
I met a guy named Jamie Swiss who does stuff like
Jamie
that.
and Swiss.
He's
He did a show for 14 years.
I don't know.
Jamie and Swiss. Yep.
He was stellar with the cards.
Yeah.
I think he kind of teaches other card guys. Okay, so I'm gonna give some stuff away and get going.
All right. I know that one.
You know what? That one
I know this one works.
Can you guys hear me okay? We're gonna get started. I'm gonna get some more junk away. Actually, this is not just junk. This is pretty special stuff because we're out of T-shirts. And actually, these aren't Shmoo shirts. Okay, who wants T-shirts? Something clean to wear tomorrow? God, I can't believe how popular T-shirts.
Look how hands go down. Like,
who needs it the most? Yeah. Okay, here's one. There's a large. Who else is large?
Living large.
A large, sorry. I hate to give everything to the front row, but I think I can hit these guys, so I'm gonna. Yeah, all right, good. Okay, this is a total liability. If you haven't seen these, they're super cool giveaways. These are actually little tiny screwdriver multi-tools. I mean, okay, if you're on the phone, you don't win. Try and catch. Oh. I shouldn't throw things in the dark.
You throw it at the camera. You practically knock the camera.
This is why I'm not allowed to throw stuff. Okay, so I just want to say a couple quick things. I honestly don't know. This is Sheeri. She's speaking next. Okay, shut up and listen. Open up. This is great. Our speaker has to tell people to shut up and listen to the introducer. Okay, so.
You don't know who I am yet. It's okay.
I'm totally stoked you guys are here. This is actually something I'm excited to have on the agenda, and I'm going to stay and listen myself because this is a huge problem that we have, right? I mean, databases are behind every app. This is why, databases arguably are to blame in part for why web apps are the low-hanging fruit for security. I just select star, right? And everything dumps in my lap. And so this is a really hard problem to solve. It gets to the core, I think, of why application security is a huge problem. And so I'm hoping that we're going to learn a lot. So anyway, pay attention and yeah.
Stuff.
And stuff.
And stuff.
Thank you.
And if you don't pay attention, the video will be.
Thanks so much for coming.
No problem. If you don't pay attention, the video will be on the web. You guys, yeah, I'm through the mic. Okay. Super. So why are databases so hard to secure? Now, I have to say that I thought this talk was going to come a little differently to me. I did like the whole proposal, and I was kind of like, okay, yeah, this will be great, whatever. And when I was trying to, do some of the technical exploits and the demos and stuff, I realized it was getting way too much into database concepts. And you guys don't want to learn about databases. You want to learn about how to secure databases. So definitely, if you're finding that it's not technical enough for you, I didn't want to go into what SQL injection is, because if you don't know what it is, you can go look it up and you'll be like, okay, quote, dash dash semicolon, okay, fine, now I know what it is. But what this talk is going to do is going to go into the concepts of this is, there is this thing called SQL injection. You can do this. It's bad, so that you guys can then go and have your have that dimension of your brain it's now there. So it's a little different from probably what you read in the thing, and that's on purpose because I figured I didn't want to talk like database syntax to y'all. too much. So that being said, I'm going to go to the next slide. I want your balls. Okay. I want you to think. You guys are not database experts. Well, not all of you. Maybe some of you are. However, if I say something and you're like, I don't get it, just like stand up. I'll probably see you. You can throw your balls at me, whatever. But think. Maybe something I say doesn't make sense. And you know what? You might be right. You might be wrong. Doesn't matter, right? Because if you have the question, 20 other people do. Ask for information. I know that, you know, when you're in like a group of like experts, you don't want to be like, so what's this WAP thing? You know, and everyone's looking at you like, dude, you're at a security conference, you don't know what WAP is. Like, you know, this is a database talk. So ask for information. I may say, hey, you know, that's too complicated, I'll get into it later. You know, let's go do lunch tomorrow. You know, look at this website for that information, or, you know, whatever. But ask. And respect me, respect you. I'll start on time, I'll end on time. Respect each other, that kind of thing. That goes with the don't be afraid to ask, because if you all don't respect each other and somebody goes, I get to know what SQL stood for, you know, it's just not going to work. So I don't really need to say this stuff, but I figured that I should. I'm going to end on time, so feel free to email me questions, and I will post them to my blog at Sheeri.com, and I'll have that stuff at the end as well. So if you don't get your question answered, I want to answer it. There's just only a limited amount of time. So. My qualifications, for security, I worked at Guardium, which does a database security appliance. So I kind of got into the whole security mindset kind of from there. In May 2001, I was a system administrator, and then starting March 2004, I was a database administrator, and I've been that ever since. I actually have a master's degree in computer science from Brandeis University, where I specialize in databases and blah, 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 blah. So. I am a MySQL DBA. So I have some experience and familiarity with Oracle, with SQL Server, with Postgres, with Sybase, with DB2, but I'm not an expert. So you might ask me a question about Oracle or SQL Server, and I'd be like, I don't know, I'll look it up and whatever. So that is that. Okay, Pythian. So the little logo at the bottom, Pythian Group, that's the company I work for. We do remote database administration. So it's kind of like outsourcing, but for the day-to-day stuff. You know, we can make sure, we can work on projects with you, just like, you know, normal consultants. You might think, oh, hire them, get a consultant. But it's really hard to find a DBA. It's even harder to find a good DBA. So it's what we do. So anyway, so what are Pythian's qualifications with regards to security? We have clients that, you know, are, whether they're media or, you know, government contracts or whatever, you know, Sarbanes-Oxley, we have to be SOX compliant, HIPAA compliant. FDA or AOE, which I actually don't work with that, so I have to go look in my notes to what that means, but somebody knows what it means. It's a compliance thing. I don't think I actually wrote what it meant. All right. Anyway, we also have to do credit cards, and not only do we have to be PCI compliant, but we have to be PCI Gateway compliant. And the EPD, the European Privacy Directive, because the Pythian Group is headquartered in Canada, so they don't just have North American contracts. Some of our customers, Western Union, they deal with financial things a little bit. Palm Data, same thing. And you could check out like the list of customers, you know, Pythian.com, about us, customers.html. I mean, everyone from like MTV and RottenTomatoes.com and whatever. So, you know, everything from, you know, who cares if you lose their password to, holy crap, don't lose that information. All right, enough of this palaver. Let's get the show on the road. Nobody threw any shmooballs at me while I was doing that spiel, so I appreciate that. Thank you very much. Now, you guys already have policies and procedures for operating systems, network, and applications. So one of the things that I'm going to do now in this next section is I'm going to talk about how securing a database is similar and different to what you already know. But start with what you already have. You already have policies and procedures for your network, for your operating systems, for your applications, for maybe your developers and their coding. So how can you apply that stuff to databases? For instance, you know, do you have something where there's an intranet, and to access the intranet, you only have SSL connections? Well, okay, maybe that's something that you want to apply it to the database, where you only connect, you know, the web server will only connect to the database over SSL. Right now, obviously, there's the performance, you know, hit of encryption and whatever. But start with what you already have, because that's, A, that's an easier argument to make, and B, start with what you know, right? The other thing to keep in mind is, with a database, sometimes it's very hard to characterize the content. So sometimes it's hard to tell the malware programs from the good ones. How do you know that you don't have, you know, how do you know that like some long-running query isn't an attack versus a really bad query from a developer, you know? You don't know. So there's not that much stuff out there right now that's doing database usage, characterization, but it's coming. And there are people that are already doing some, you know, some basic stuff. So, general security. So these are the things that you already do. Patch me if you can. There are a lot of vulnerabilities out there for many databases that there are no patches for, but there's plenty of security releases that never make it in there because people are lazy or they're like, well, this is our bank database and we don't want to upgrade it because things might break. You know, so they're on an IBM mainframe running, you know, from like 30 years ago and they're running, you know, Oracle 6 or something. So yeah, if a patch exists and you can patch it, that's a general security thing. You do that with a lot of stuff. Again, starting with what you know. Some of the general security things are preventing access, like through firewalls. You probably all read that study that came out a couple months ago that said that, you know, 60% of all databases are just open to the net. You know, if you have a web application, you probably don't need that. I mean, if you're running a service where people can connect to databases and play around with them, which there are out there, you know, then you want that. But pretty much for the most part, you probably don't want people to directly access your database. You're doing it through some kind of interface. And the other thing is you want to be able to prevent meaningful knowledge, right? If somebody steals your, you know, encrypted hard disk, it's going to take them a while to figure out that information. This is also one of those things that, like, if you're the Pentagon, you have to worry about this. If you are one of a million different kinds of sites that might have financial data, right, you're not the shiny red Corvette that people want to steal. You just want to be able to, like, outrun the other guy or be the one car in the parking lot that doesn't have its doors open, right? So there's different levels of security, and depending on where you work, you know, you might have the goal of, well, we just need to be more secure than most of the other people. We need to not be a low-hanging fruit. Or you might be like, well, you know, we're the Department of Defense. We need the best security possible, period. So think of that when you're doing your risk assessments and stuff. But of course, you've already done that, right? You already have all these plans and policies in place. So encryption and permissions, right? If somebody has a login to the box and they can't read a configuration file, you know, that's part of security. So I'm going to talk a little bit about network security. Now, again, I am not a network guru. So again, I might say things that are wrong, and feel free to throw things at me or yell at me or whatever, or just say things. You have physical access and isolation, right? If you can unplug a cable, then, you know, you rule the world. Also, wireless. This is the whole point about wireless. You know, everyone's talking wireless security. Well, why is wireless security such a big deal? Nobody really talks about, well, what happens if you get on like a LAN and whatever? Well, it's the same thing. It's just it's a lot easier to get on a wireless network than it is on LAN. You know, you could sniff packets over a LAN too, right? It's just easier to sniff packets on the wireless because nobody knows you're there, right? Because you're in the Starbucks across the street. Authentication, again, ACLs. And then traffic shaping, right? So not just, you know, get rid of Napster or LimeWire or Azurius or whatever, BitTorrent, but, you know, getting patterns, right? I mean, if you work at a university, 95% of the traffic is BitTorrent and whatnot, but, you know, if all of a sudden you start seeing like web traffic or SSH traffic out being 20% of your traffic, you know, there's probably like some kind of bot or some kind of malware installed that's having all this traffic. So knowing your patterns, also volume, you know, you can denial of service. You know, it's really easy to denial of service database. I mean, all you have to do is really load test somebody's application. Load test. Anyway, so again, there's a lot of, with database security and with applications, especially web applications in general, you have a problem because you need to access that data. You need that to be there. So you can't really not allow it. So let's see. Right. Oh, so one of the other ways that you can do content shaping is by user education, right? You can say, don't email passwords because it's plain text, right? You can't really say, don't, you know, look at somebody's credit card number if they're supposed to because they have a subpoena, you know? I mean, all right, securing an operating system, again, authentication with ACLs. You've got a firewall on the thing, and you might use IP tables or something. The installed programs, you know, configurations, the user ACLs, what can people see, what can people not see. You know, a lot of times you're just going to try to not give people a login. You know, you don't run Apache these days. You don't even run it as the nobody user because there might be more than one program that have the access to the nobody user. You run it as the Apache user. So if they can log in, they can only get Apache. Securing third-party applications, again, authentication, you know, the configuration, the files, and how you do it, and content shaping, right? If the application all of a sudden starts doing something that's not supposed to, well, either somebody turned on an option or, you know, something's going a little weird. So, let's see. Did I get anything? Are there any questions or anything before I move on? No? Bueller? Anyone? Anyone? Great. Super. Oh, I'm going to go over here. Oh, did I just move the thing? Yes. Okay. So, applications, your own applications, not the third party, your own party, right? Again, authentication, who can log in, when, where they can log in from, configuration, and, you know, user entered data, right? I'm not going to go into SQL injection here. You guys can look it up. You're very smart. If you don't already know it already, you can be like, oh, she said that this is vulnerable SQL injection. I'm going to look up exactly what the syntax is. So, even if it's checked elsewhere, user entered data, you know, if you check it on one page and then go to the next page, well, you know, I can have a page over here that posts the data to that page. So even if you assume on this page that it's already been authenticated because it got to the page, maybe not such a great idea unless you can actually prevent that kind of access. One of the other things about securing things like applications is if you have something like a command line application or even a desktop application, if you're, you know, logging into the database directly and you've got a history file of the commands you've typed and you type your password on the command line, yeah, you're going to be able to see that. And you can do that, I mean, with Oracle, with MySQL, you can do that. So you have to be careful about that kind of thing. All right, super. So now, what is a database? Well, that's great. I looked up on like some dictionaries and Wikipedia and whatever. Basically, it's a structured collection of records. I mean, you could have a text file. This is why, you know, SQLite was in the description, even though there's no real examples or whatever. I mean, what makes it different from a text file? Well, it's structured, right? So Excel could theoretically be thought of as a database. So it's a collection of records. But when people say database, they usually mean a DBMS, which is a database management system, which isn't just the collection of records, which is the storage. It's the storage and the retrieval, because that's kind of important, and actual processing. A lot of people try not to do too much processing in the database. There's pros and cons, but you can do it, and it's useful in many, many cases to actually have your DBMS do a lot of processing. Alrighty. Next. Hello. Next. Here we go. Database security in general. The biggest problem with database security is there are so many places and so many parties that are responsible for it. You've got the developers have to write the secure code so you don't get hacked. You have to have the DBA to make sure that the user permissions, the configurations are there. You have to make sure the OS is secure, because if people can log on and read the config, then you have to make sure the network's secure, because anyone can run TCP dump and put the packets together and find out what you sent to the server. So, there's a lot in there. That's four different groups. Now, in some smaller companies, that might be one group. That might be the IT department. But in a lot of places, you have the NOC, you have the systems group, you have the developer group, you have the DBA group, and you might, on top of that, have a security group on top of that. I mean, that's a ridiculous amount of cats to herd and get to agree. So that's really one of the biggest problems. And the other thing is databases are designed to store this information. You can't just say, like I said before, don't email out social security numbers, don't email out credit card numbers. You do have to say, hey, I know you got this database extract. Don't forward it to your colleagues via email. That's important too. But that's not really, I wouldn't really consider that in the realm of database stuff. That's really more of an email thing. Don't email sensitive data. But the database is designed to store and retrieve this sensitive information. So how do you make sure that it's stored and retrieved by the right people at the right times? There's also a whole bunch of varied information and related information. What I mean by that is, when the whole search engine thing happened, and they're like, oh, the records are, they're numbered or whatever, you can't figure out who it is. Well, guess what? They took the related information and the varied information, they put them together, and they could figure out who was doing what, and it was a huge security thing. It's a huge privacy invasion. So even if you think, well, who cares, they get my Facebook password. Well, if there's related information to my Gmail password, and then in my Gmail, well, once they can secure my Gmail, they go to my bank and they say, I forgot my password, please email it to me. Or I forgot my password, please email me a link to go change it. Well, they got my email, so game over. Om nom nom, I had your data and I eated it. Okay, you guys are still awake. Super. Om nom nom. I'm sorry? ICANN has credit cards. Okay, thanks, bye. Super! Just wait till we get to one of the ending slides where I compare database security to an orgy. But, you have to wait till the end for that one. Database security in general, information gained in one part can damage another, right? If I get a login to Facebook, I might be able to actually get somebody's information that they store in a Facebook app, which might include credit card information. Even though it's a different user or something, I've gained access to the database, and then from that I can find out more things. And there's a lot of access points, but I've already talked about it. The database management system itself controls the permissions, who can log in and where they're from. The operating system, the network, the applications control access, like physical access not physical access, but actual, can I ping this database? Can I get to this database? And the applications control the interfaces. And the hand that rocks the cradle rules the world. So application vulnerabilities, any data the interface can access might be compromised. This is not a lecture on how to make your code more secure. However, there's so many ways your code could be not secure. And again, because developers are really great with procedural languages or object-oriented languages, and SQL is a declarative language, which means you declare what you want, you don't declare how you do it. You don't say, okay, so go through this for loop and for each one do this, that, and the other. Thanks. Are you? Yes, more balls! Do you have a question?
No, I'm in here for a talk on why databases are hard to secure, and all we've heard is Facebook and email. And I guess my question is, are we going to talk about databases, or are we just going to be very general through this whole talk?
Well, you probably missed the first part where I said I'm really sorry that the description said we're going to be really technical and we're not.
No, I'm not that.
Okay, super.
I guess we're just kind of getting some real general stuff in here, and are we going to talk about databases at any time?
I'm glad you asked. Because how can we secure these? Otherwise, I have to stand up here a long time where you throw shmoo balls at me. Seriously, this was my next slide. I totally did not make this up. I'm like, well, I know it's later. Let me skip ahead a couple slides.
Seriously went and just bought 2 shmoo balls.
Seriously, damn, I'm good. That's all I have to say is I anticipated you guys hating me, right? Okay, auditing and monitoring. Prevention is one part of security. Another part is auditing so that you can fire someone later when they steal your credit card stuff. And you want to monitor because you want to know when somebody's in the middle of stealing your database security stuff. There are a bunch of companies that are doing this for lots of different database systems, so I'm not being general here. But RippleTech.com has something for MySQL and Oracle. Guardium.com, which I mentioned earlier, has Sybase SQL Server, Oracle, MySQL, and these are things where you buy like a $50,000 appliance, you put it on, in front of the things or on your network, and it might act as a proxy, it might not, and it makes these audit trails and stuff. Now again, a lot of people will say, okay, well let me just make history tables for everything. Well, you can do that, but that's a lot of overhead, right? So you want to deal with the CIA principles, right? You want it to be confidential, you want it to be independent, and then I forget what the A is, but I always forget what the A is. So, if anyone knows. Accessible, yes, because we want the data to be accessible. Yeah, usually that's not a problem. Usually the data is a little too accessible. But you want it to be independent, right? You don't want your database auditing to get in the way of the database. And most, like SQL Server, you can turn on auditing, and Oracle, you can turn on auditing. But that doesn't really help because, first of all, the DBA can go and delete rows from the audit tables. It's not independent. It's on the same system. So not only is it bad because it's going to ruin the performance of your application, but it's bad because it doesn't even, who watches the watchers, right? If you trust me, great. great, but guess what? It's the DBAs that run off with the credit card numbers. So hard to do. You can audit with triggers so that you're not auditing every single change or view to every single object. That is one thing that you can do, and that is important. But again, you have to think and plan. This might be stuff you already know, and if you want to leave, that's great. But you know, thinking is so not done in so many ways, and it's really hard. And you could tell just by my facial expressions that I have 20,000 rants on that. So access points to the database. Who can log in? Well, you have the network, seeing traffic. That is, on the MySQL Forge, that's actually a code snippet. It's like a TCP dump code snippet. So you can sit on the network and sniff the traffic and get all of the queries that are going back and forth, including things like set password equal to password, open paren, quote, whatever the password is, right? And again, there's not only a bash history or whatever, you know, shell history, there's also a MySQL history file. So for MySQL, that's something that if you set a password, well, great. If someone can go and look at your history and see what you set the password to, that's great. You know, you're compromised. There goes your data. So the access points on the data, you've got the data files themselves. You know, strings is a wonderful thing. You've got the log files. You've got the backups. If you're doing something like replication, whether it's Oracle, whether it's, you know, MySQL replication, it has to get the information from one place to another. And it might be being done by data blocks, you know, transferring data blocks over. It might be being done, you know, manually by rsync, which is kind of the same thing. And it might be being done by statements in a log, and the statements get moved. Again, somebody can intercept that stuff. They now can get your entire schema. They can find the user table. Maybe it's not users. Let me just check my notes here so that I can have things. All right. I think I'm actually at the point where oh, yeah, who can log in? I'm actually going to show some examples after this slide. Who can log in to the database? From where? What can they do? What consequences can they bring about? If anyone can read all of the tables in a certain database, then maybe you shouldn't put the sensitive information in something that anyone can read. Again, you know, data, you have access control. You can have, now here's the thing. Here's the stuff that you might know, you might not know. You can have access control level in every single major database management system. You have access control on objects like databases themselves, the tables in the database, the columns in the tables. So you can say, okay, Sheeri can look at everything except for this one column, this one database, and also store procedures, who can execute them, who cannot. You can use views, which is also another way to say, okay, Sheeri can't access this table with important data, but she can access this view, and the view is everything in that table but the important data. And in order to do that, you have to figure out, well, what's sensitive, what's important. You know, do you need to encrypt your backups? How important is it? Are you backing up your code that has your algorithms in them for encrypting the data with, you know, are you backing them up in the same place? Okay, so here's some code. I'm not necessarily going to go through and explain it all, but it's probably pretty, you know, obvious what it is. You know, there's default table spaces. If your default table space is the system table space, then you can do some damage, right? You could stuff it full of data so that there's no room left. It's like stuffing your var partition full, right? Nothing will work. Temporary table space, same thing. If you have a temporary table space, you know, if I have a temporary table space and the web app has a temporary table space and I fill it up and the web app can't do anything now because now it can't make a temporary table when it tries to do a huge join, great, I've just denial of service the, you know, the database because, you know, whether it was on purpose or not. Quota, that's another thing that you could say, okay, well, I don't want them to have an unlimited quota. I'll give them a quota. Profile is a role that they have, so you can give them the sysdba profile or the sysadmin profile in SQL Server. You can expire the password. You can lock or unlock the account. This is actually Oracle, actually, by the way. So in MySQL, you grant a privilege type, and there's huge amounts of privilege types, everything from select and update to things like replication and super. There's a super privilege. And you can do it on a table, a database name, like everything in a database, everything in a database or a table, on a routine, which is store procedure, to a user. That user string includes a host, and you can require it to have and require will require X509 requires it to have a particular certificate. If you say issuer, it has to have an issue by Can I take back that part where I said I want your balls? No, sorry. The issuer is you have to have a certificate by a particular issuer. So if you need to have a particular certificate by like yahoo.com. You know, you guys actually, you know, the balls are there if you can't get a word in edgewise. And I haven't seen like a hand raised or somebody try to be like, hey, sure. An actual question, okay.
The question is, if we apply these privileges across these different granularities, does it have either an impact on the performance of the system, or is there any kind of information disclosure that comes from running up against one of these? You're granted this, but not granted that, and it acts differently. So it's sort of a two-part.
Great. So it's a two-part question. I'm going to name the two parts because then if I forget it, you all can remind me as opposed to just one person reminding me. The first part was, is there any impact on performance when you grant things? The second part, is there any information disclosure? You know, kind of like if you put in a username and password and it says password isn't good, and then you type in a bad username, does it say like, well, username is not good? There is some information. It will say you don't have permissions to access this table or this database, but it will say that whether or not it exists. If you have access to like an entire database and you try the users table, it will say user table doesn't exist. But if you don't have access to it, if you try to like go to, you know, important information .user, it will say, you know, you don't have privileges to that. And the databases, I believe, I'm not completely sure about all of them, but I believe they differ in whether or not they actually disclose whether the database exists and you don't have permission or not. I know MySQL will be like, nope, you don't have permission, as opposed to, nope, it doesn't exist, or you don't have any permission. And then that was the second part. The first part was, does it have impact on performance?
When you start granting this and that and the other, you've got this huge matrix of who can see what. At what point does it degrade the performance itself? Does it?
It does. I don't know about the other database systems. MySQL keeps a system table in memory. I mean, it's a pretty small table. I mean, are you going to have thousands and thousands of users? Hopefully, that's not the way your application is designed. You know, if the purpose of the database is to have 1,000 users and they're not in a particular application table, and that's a good, smart, good decision, then yeah, it's going to be really impactful. But if you have, say, 100 users and permissions, that's great. The other thing is you can use wildcards and things like hosts. So you can say everyone on this subnet. You can also use subnets like, you know, 16.12.0.0/24 if you want. So you don't actually need to have like every host and every, you know, thing. You can use %, as the wildcard symbol, or an underscore as one wildcard character. So you shouldn't have to have that much. And in MySQL, it will impact performance. I have to think that it will impact no matter what, because when you go into a shell like SQL Plus, a database shell, and you're connected, it has to test to make sure that you have those privileges. I know MySQL actually tests the authentication information, the whole, like, you have a key and it sends it over and it's like, okay, you did authenticate, and now, you know, okay, can you get this table? Yes. And even if you've gotten the table before, it'll look to see, okay, do they have access to the table now? Any other actual questions? Yes, you in the front. I'll get you.
Can you provide an opinion on whether or not it's better, like say if you had a sensitive operation like encrypting credit card numbers, would you rather see that in the application space, or would you want to push it off to a procedural language in, say, the PBMS space?
Well, let me get to my notes on that, because I want to make sure that I get everything that I want to say on that. The opinion is there's pros and cons. So the question is, if you have some sensitive like algorithm like encrypting your passwords, is it better to have it in the code, or is it better to have it in the stored procedure? You know, or hey, is it better to have it like as close to the user as possible, like in JavaScript or something, right? So that way it only transmits across the wire encrypted or something. That he didn't say that. I made that crappy part up, as you could tell. And the answer is, it really depends, because the problem with that kind of thing is when you back up your data, are you backing up your algorithms and your code in the same place? You know, what are your policies on that? If your policy is, well, the backups are really secure, they're with, you know, Iron Mountain and we're not going to worry about it, then great. The other problem is that that database code is kind of a black box, which is a good thing and a bad thing. So you can say to the developers, okay, you know, run this query, you know, delete user, or run this query, encrypt password. And they don't have to know how it works underneath, which means that you can make performance really fast. The database administrator can be in charge of changing that, fixing that. But that's kind of a double-edged sword, because then you don't necessarily have the same testing procedures. Even in shops that have a lot of, you know, PLSQL, there's not really a lot of source control. And I mean, some shops do have it, some shops don't, but most of the time it's like database administrator waves their hands and black magic happens, and ooh, we've got this function, and now it's faster, and now they say it's more secure. So the answer is it depends, but those are the factors involved. Did that answer your question? Does anyone have any other factors that might be involved there? Super. You in the back that stood up before, and I'll get you.
This is great. I would really love it if my developers developed their applications with user authentication in the database.
Okay.
In 15 years in the business, I've never seen any developer I've ever worked with do this. It's always their application logs into the database with a static user, and they create their own user tables within their application database, authenticate the users that way. They do all their rights management within the application, how do we convince our developers to trust the freaking database and use the database, user tables and grants and ACLs, rather than rolling their own in their app? Because then this happens in web apps, this happens in three-tiered systems, you know, everywhere I've ever been, I've seen this happen over and over again.
Right. It depends what extreme you take it to. First, you have to convince your developers and your database administrators to get along. In fact, you know, I was talking to somebody yesterday, like, oh, you're speaking a green badge. What are you talking about? Well, I'm talking about why our database is so hard to secure. And no shit, what he told me was, well, that's, you know, why our database is so hard to secure. They're so hard to secure because DBAs are stupid. And I was like, well, super. Like, A, I'm a DBA. B, do you know how many times I hear from the DBA, like the DBAs hate the developers and the DBAs, like, it's a systems problem, it's a code problem, it's a this problem. You all have to work together. That's all I have to say. We all have to work together, right? So part of it is getting whatever policies you have for user management, if you wanted to go that route, which is a good route, right? Because it's already a problem that's been solved by the database management system. Oracle's already solved that problem of how to do user auth. MySQL solved that problem. Postgres solved that problem. SQL Server solved that problem. Now, Microsoft SQL Server is an interesting beast because you have to have a login on the box to have a login to the database. You don't actually have to be able to have a shell on it, but you have to use some kind of authentication if it's, you know, on the box or Active Directory or something. It has to exist. So that's something that SQL Server is not so great at. Again, though, you can have, you know, it's kind of like on Unix where you have a shell account for Apache, but you don't give it, you give it bin false as the login. So it's not like the worst security vulnerability in the world. But, you know, and again, now you have to deal with your Windows admins, you know, the sysadmins. So it's a hard problem to solve because now you have to involve a lot of groups as opposed to the developers who are like, yeah, no, we'll just create this table and we'll do this and it'll be fine. The other problem is that, so if there's some web app or whatever, and, you know, so now I have a login and you have a login, are you going to give me and you different tables so that I can't see your table and you can't see my table? Like, how many thousands of databases and tables are you going to create then? That's going to create a lot of overhead with a lot of these database management systems. When you look at a table, you're opening a file. So there's only so many file descriptors you have on the system. So you can bork yourself that way, and that's probably why. I mean, the answer is, I think, because it's too hard. That doesn't mean it's impossible, but it just means that.
How often do you see it actually implemented like you're talking about?
Never. Never. I have never seen it happen that way. Certainly not for like a web app or whatever. And it's hard because then you have to manage all of those. It's really hard. Certainly, I've also seen people try to be smart about it and say, well, here's the web app user that can write the permissions, and here's the web app user that can read the permissions, and we're going to use this user for this and that user for that. But guess what? They're stored in the same config file. So, I mean, you know, what happens if you break into Apache or you break into the IIS user? Now you're, well, not that Apache's ever had any vulnerabilities, ever. Right, so you break in and you become, you know, the Apache user, and let's say they allow a login on the system because that's how they restart it or something. Well, now, even if it's outside of the web directory, you can read the connection string. So now you have the database username and password.
That's assuming that the application is implemented at the presentation tier, not at the application tier.
Correct. That is assuming that the application is connected to the database at the application tier, not the presentation layer, not the application layer. And when you have things like Tomcat and whatnot, you're absolutely right. You know, you have app servers. Now they also have their own vulnerabilities. So again, I mean, somewhere, right, the connection information is stored. Otherwise, how does one server talk to another? You know, it's kind of like, you know, SSH keys, right? Theoretically, if somebody breaks into one box and there's SSH keys in another box, well, now they can log in. So if somebody breaks into one, you know, if server A has access to database B and you break into server A, well, now you have access to database B. Right, exactly, which is why you should be implementing it in middle tier. But if you break into the middle tier, then you could still do it. And again, I'm not saying don't implement it in the middle tier. I'm just saying implementing it in the middle tier is better than implementing it in the presentation layer. However, that doesn't mean you should go home and sleep well at night. You know, you should never sleep well at night because your data will be eaten. And that's one of the problems that I have with everyone, with DBAs like myself. It's like, well, you know, it's secure. Well, how secure is it? So here's Postgres. It's got fewer things, but again, groups, you've got roles, so that's easier for authentication. You know, maybe something using, MySQL doesn't have roles, but SQL Server, Postgres, Oracle have roles, so that might be something where you can create 1,000 users and give them these roles and say, okay, you can see this. Did you have a question?
Yeah, you described a universe where you have basically a free-for-all between different groups that have responsibility, typical distributed responsibility and accountability. Is there any place that is developing standards for the governance of this kind of stuff, as opposed to focusing it on a technical level and looking at, you know, I mean, maybe the mid-tier is a place to focus, but another place to look is governance.
Okay, so the question is, are there people working on standards of governance of this whole universe of security, from, you know, the network to the operating system to the database to the middle tier to the presentation layer? You know, are there any organizations? I haven't looked into it. I haven't heard of any, but I haven't really researched it. But that, I mean, that's pretty much what my presentation is, right? Is for you guys to go and like develop your policies at your institution, you know, using the ones you already have. It's hard to do because there are so many groups. And if it's all one department, they probably don't have time to do this stuff. So it's a difficult problem, but it is one we need to solve. And, you know, the problem is that you need, the more access to things we have, the more access to things we demand. And the easier, you know, we have, the easier we want. I mean, hey, I think OpenID is a great thing. It also kind of scares me. Because think about it. Now, instead of having separate passwords for everything, you have like one login in the server. And yeah, you have to trust the server, but one day that might be compromised. You know, it's, how is OpenID different from like a governmental ID system? Well, I trust non-governmental organizations more, so long as they're making money. It's hard. It's really hard. And there's no one perfect solution. If there was, I'd give it and the talk would be over. And I wouldn't have any schmoobles. Anyone else want to throw schmooble at me? That was actually kind of not too bad. I live to tell. All right. SQL Server. You can actually specify a one-way hash or a two-way hash. Isn't that wonderful? I don't know why they developed it that way, but if you really want a reversible hash in SQL Server for your password, you can have one. Super. All right. And again, without login is actually, oh, let me look at my notes because I don't want to get that wrong. Without login, oh, it connects to other databases as a guest. So you can actually log into other databases, other realms. if you want to think about it that way, as a guest, which doesn't have any connect, by default, guest doesn't have any connect privileges, so you're not really giving any permissions. But you have to be careful when you do say, well, I want the guest to be able to read all the tables in this database. You have to realize that every single other user might be able to do that if they get without login. Anyway, this is just kind of to illustrate how there's different permissions for different things. There's different things you can create. You might not realize, for instance, that in like MySQL, you actually, like with option, some of the options are things like max connections per hour, max queries per hour, max updates per hour. So you can actually specify that kind of access control, not just this user from this host, but you can actually characterize, you know, that data somewhat. But again, you know, if you have a runaway application that is runaway because of bad code, how do you know if it's bad code that was, you know, oops, a developer screwed up, or bad code that's, oops, you know, somebody malicious got into the system? So other ACLs, object access, we talked about, connections, databases, tables, columns, whether or not they can look at the columns or change the columns, whether or not they can look at the data, change the datas, whether or not they can execute stored procedures. And stored procedures in general, yes. Sorry, man. The other talks that I'm competing with are online, so I hope you can get something out of them. You know, it's that's the way it goes. I can't please everyone all the time. Oh, password. So password policies. Some SQL Server and Oracle, you can actually specify the constraints on the passwords themselves, including password expiry. MySQL, you can't. You can give the grant option to others, so you can say, okay, whatever permissions you have, you can give to others. Some of the password policies in Oracle are, besides the password verifying function, are failed login attempts, password lifetime, password reuse time, how many times you can reuse one in a row, the password lock time, and how much grace time you have during that lock period. In SQL Server, you can use Kerberos authentication or NTLM authentication. You can actually specify a minimum password age. This is a very Microsoft thing, so that, you know, I can't change my password 3 times in a row to say, okay, my password is A, now I'm going to change it to B, now I'm going to change it to C, now I'm going to change it back to A, so that somebody can't just use the same password over and over. MySQL. Microsoft does that in their operating system too. And you have roles as well, as I was talking about. In SQL Server and Oracle, you have sysdba is a root role for Oracle, and for SQL Server it's called security admin. There's a root user in MySQL that starts out with the default privileges of super, but you can delete that, it doesn't matter. There's nothing special about somebody who has lots of powers in MySQL, it's just whatever. As long as you give them the powers, it doesn't matter what name they have. Whereas because of the roles and the groups, Oracle and SQL Server start out with these roles and groups. So let's see. Who and where? A lot of the usernames are actually user at host. Actually, that was a good place to break if anyone had any more balls they want to throw at me. Anyone else want to leave? I understand it's not very technical, and I lied to you in the description, so feel free, really.
So is all this mess of policies and set and unset and data points, user columns, is that causing that quality of database to be secure, or is it caused by?
So the question is the access control mess that I'm showing you right now, is that the cause or the symptom of database security? The answer is kind of yes. I mean, this is only just one part of it, right? Well, I mean, is user authentication on an operating system the cause or the symptom of how hard it is to log into a system? It's just one of the... I'm not that bad, am I? Can you just turn off the mic? basically unusable. You implement it in the middle tier, yes. And then can that middle tier be compromised? I'm not a middleware expert. So I'm guessing the answer is it's not entirely secure. It's more secure, but you also need more developers who have more education about these things. It's way too easy to learn PHP on your lunch break and go to MySQL and type show databases, create database blah, and just do it. Every single example and every single book out there has how to do it. So if you can make money doing it, who cares that in a year or two you're going to have to worry about security, right? I can make money now doing it.
I'm going to say the people in the room here.
Right, well, that's what I'm saying. I'm just saying this is how the problem comes about. So I think a lot of it is education, and that's one of the things I'm trying to do, and maybe y'all already knew all this stuff, but I'm trying to just basically say, here are the things that you can secure. You can use roles in most database management systems. You can, talk about maximum connections per hour. You can expire passwords. Expiring even a web app password is great, because then you find all those little oh, somebody wanted a report, so I just wrote this thing and I hard-coded the password into it. You find those pretty quickly if you expire your passwords on a regular basis. Speaking of users, who owns the application user account? Who's responsible for that security? Here's everybody's little Bobby tables, right? If you use, so here's the thing, if you use stored procedures, right, you're never going to have this problem. If you code a lot, there's a whole movement to say, well, just use stored procedures for everything. Don't let developers write any SQL code. Don't let any ORMs write any SQL code because they're awful. And then you'll never have this problem because you don't actually have permission to drop table users. You have permission to, add user, right? The add user function or the drop user function. So you could still theoretically, if you hacked into the database and found out all of the usernames, you could probably drop all the usernames. Take a lot longer. So, okay, here's the thing. If you hated my presentation, email me and tell me. You have another question? Great.
We've got another presenter that needs to be setting up, so
That's fine.
Take them outside.
I have 2:53 on my watch, but sure. If people want to come and throw shmoo balls at me, I'll be just outside. And seriously, I'd rather know you hated it than you loved it, because if you loved it, then I did it right. And if you hated it, I need to change something.
Thank you.
Thank you. What time do other people have? I have
We have to get over to the rooms.
I'm sorry?
We have to get to the other rooms. We're not staying here for the next.
Oh, no, I know. No, they were saying they need somebody to present, and I'm like, I got 5 more minutes before I wanted to give somebody else 5